All right, so in this problem, it says determine the quantity of heat. All right, so we're looking for the quantity of heat, so we're looking for joules, also known as Q, of required to raise the temperature. All right, so we're talking about temperature of a cup of water from 293.5 Kelvin to 368.8 Kelvin. So there we go, we got some temperatures, delta T. The volume of water is 250 milliliters. All right, this might throw up a red flag for you because we've been talking about water in terms of grams. So this is a great example for us to talk about how to convert from milliliters to grams. And in this problem, they know it's the first time you've seen it, so they also put, and the density of water is 1.00 grams per milliliter. So that's the conversion factor to go from 250 milliliters to 250 grams, or to however many grams it is. All right, so let's do that first. So 250 milliliters over 1. Milliliters is going to go on the bottom. And then from this conversion factor, grams will go on top. And since it's 1.00 grams, it's going to be 1.00 grams on the top, 1 milliliter on the bottom, and mathematically it didn't change anything, right? Milliliters cancels out, and you get 250 grams of water. All right. Now, if you remember when we actually did the density lab and we calculated the density of water, depending on where you are, it could be slightly less or slightly more than 1. But whenever we're doing these kind of problems, just assume that it's the constant. It's just 1.00 grams per milliliter. Okay, so now we have a mass of water. All right, so we have mass. We have the specific heat of water. They gave us that. And they're asking for the answer in kilojoules. Okay, so let's write down the equation first. We have Q equals Cm delta T. So C is 4.184 joules over grams times Kelvin. The mass we just figured out is 250 grams. And then the delta T, remember delta T is the T final minus T initial. So the final is 368.8 Kelvin minus 293.5 Kelvin. When you subtract them, you'll get 75.3 Kelvin. All right, so now let's cancel some stuff out. So Kelvin cancels out, grams cancels out. That leaves us with joules, Q. And now we just have to multiply it all together, and you're going to get 78,763 joules. Now, in the problem, they asked you to change that to kilojoules. So, what's the conversion factor? Well, let's figure it out. So there's our joules. Joules is going to go on the bottom. Kilojoules is going to go on the top. And the reason is so that joules can cancel out, right? We want these to cancel out. Now, what's the conversion factor between joules and kilojoules? Yeah, exactly. There's 1,000 joules in 1 kilojoule. So you're basically going to take that 78,000 and divide it by 1,000. And that will give you the kilojoules. So that's going to give us 78.763 kilojoules. We're not done yet because we have to talk about Sig Figs. If we go back up, the temperatures, they have 4 Sig Figs. This is a constant, so we kind of ignore it. And then we have 250 only has 2 Sig Figs. So we have to round this to 2 Sig Figs. So the 7 and 8 are good, and then we just look at the 7. Because it's above 5, it's going to bump this up to 79 kilojoules, and that's going to be our answer for this problem.